Welcome back to lesson 2.2. Today we'll be graphing systems of inequalities. So what that means is we'll be graphing more than one inequality at a time and determining what we call the feasible region. Let's write that word down. We're looking for the feasible region. Feasible region will be the solution, or rather the two shaded areas, or the shaded areas that overlap each other. So let's dive into the first problem, see what it looks like, and then also see how we would type it in into delta math to get the correct answer. So our first equation, we'd have two equations written in slope-intercept form, rather than inequalities. So our first step is we have to graph these two equations. And this builds into what we were doing last week in the prior day. So we'll make this the blue equation, we'll make this the red equation, and we'll go ahead and graph them. So for our blue equation, I have a y-intercept of -4, and I have a slope of +2, so up 2 over 1. So my b is -4, my slope is 2 over 1, and if I plot those points, I get something to that extent. Now, there's my points. Step 2 is determining if this is a solid or dotted line. Because it is a greater or equal to equation, it'll be a solid line. And which side do I shade in? If I were to plug in the point 0, 0 into the equation, would it be true? Is 0 greater than 2 times 0 minus 4? In this case, that would be. That is a true statement. 0 is greater. So I am going to shade on the side that has 0, 0. Shading on that side. Now I'm going to graph that second equation. That second equation has a y-intercept of +2 and a slope of -1 over 1. So again, start at +2. That slope of -1. Plotting my points, plotting my points. Now if I sketch this graph, it is a solid or dotted line. In this case, it would be a dotted line because it is just a greater than. So my equation will look something like that. And then we have to decide, do we shade above or below? Again, I like to test with 0, 0. If I plug that in, is 0 greater than -0 plus 2? In that case, that would not be true. Because that is not true, I'm going to shade so I don't include the value of 0. So I'm going to shade in this direction. So we just graphed two lines. Now what we're looking for when we graph systems of equations is really we're looking for this overlap. So this region that got shaded by both lines. So that green area is what we call the feasible solution. Feasible solution or feasible range. There's two ways you can say it. So, but every point in that shaded region, in that green area, our region, call that feasible region. Anything within that shaded green area would be a correct answer. So, when we're trying to select an answer, if we're looking for what would be the solution, you can pick any point within here. Any point within there would work. So like for delta math, it says pick a point. There are literally millions of points you could pick. I'm just going to make it, how about this one? I'm going to go up to here. We'll use the point, that looks to be like +10, the point 0, +10. So I can use the point 0, +10, and that would be a solution. You could pick something else. You could pick, honestly, anything within the shaded in region. So if you wanted 0.1729, there's a whole bunch of different answers you could have used. You could use decimals if you wanted to, but ultimately you're just looking or picking one of the points in that shaded region that got shaded by both lines. So that's this idea of solving systems of equations. Graph the lines, look where they overlap. Now we will see, oftentimes this is put into the point of a word problem. Put some context behind it. So let's look at the problem here. You can pause the video to read the situation, but we're looking to sell tickets for a show. There are student tickets. Student tickets will represent with the variable X, and we have adult tickets will represent those with the variable Y. So in the instructions it says the theater can hold at most 150 people. So the number of tickets we can sell in combination, student and adult, can't be greater than 150. So what I'm going to do is I can use that information to write my first inequality. The number of student tickets plus the number of adult tickets has to be less than or equal to 150. It's how the theater is limited. Additionally, we said we have to make at least $960. So I can say the cost of a student ticket plus the cost of the adult ticket. Oops, the cost was $8, not $9. So the cost times how many we purchased, that has to be greater than 960. Again, that equation is it's $5 per student ticket times X is how many student tickets, $8 per adult ticket times Y, how many adult tickets I sell, and in combination, that has to be greater than 960. So those are the two inequalities that I'm going to have to end up solving for, or rather graphing for. So let's label them. Let's call this equation 1 and equation 2. If we were to rewrite them, equation 1, we can subtract out. Equation 1, this would actually be a less than sign. You'd have to use that drop down to change that to a less than equal to negative x plus 150. And then you can use the plot in the shade to get that line graph at the bottom. And then you could do the second equation. The second equation, if you solve, that'd be a minus 5x. You get 8y is greater or equal to, let's give myself a little more room. Negative 5x plus 960. Divide everything by 8. You would get y is greater or equal to, I'm just going to leave that as negative 5/8 x plus 120. Again, typing that in, negative 5/8 x plus 120. Now for a problem like this, if you're using delta math, let's go ahead and see an example of this. So I could type in those two equations again. That first one was negative x plus 150. I could come over here and type in my negative x plus 150. I could change that to that less than equal to. And I could plot that. Oh, this is a different problem, so it gave me wrong. But you could type that equation in, and it'll plot the line, and you could shade which way you want it to. So you just type it in, and this one's actually going to shade and graph for you, so we're not going to have to worry so much about the graphing purpose. So for here, so again, this will do the graphing for us. That saves us a few steps there, but I'll go ahead and do that for us real quick. I'll graph that line. That first line is going to look something like there, and this is going to be shaded down. That second line is going to be 120. Let's go up 5, 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6, 7, 8. It's going to look something like this, and we're going to shade above. So in this problem, that solution region is going to be this little shape right there. That little shape right there. So again, it's going to ask, the problem is what is a possible solution? So just pick any point within that little area. Maybe you pick that point right there, that point that's 0, 140. 140 adult tickets, it would work. But again, that solution region is where those two overlap each other. Again, let's try one more problem. Let's see if we can get these equations set up, and then I'll leave you to try to graph it on your own. So it says, here we go. We're working some summer jobs. I'll let you read the description of it, but we are going to use X is going to represent her tutoring hours. Her clearing tables will be the Y. So we got a couple things going on here. It says in a given week she can work a maximum of 13 hours. So that means x plus y has to be less than or equal to 13. How many hours doing both combined has to be less than 13. That was the first equation. It also says she must earn at least $160. So that means $21 times x times how many hours she tutors plus 8y has to be greater or equal to 160. She works at most 7 hours tutoring. X is tutoring, so x has to be less than or equal to 7. And then a minimum of 3 hours clearing tables. Y has to be greater or equal to 3. Those would be the 4 equations we would have to type into our equation. Now, yes, those first two you'd have to rewrite them a little bit, but so you could type those equations in to get them plotted, to get them graphed. Hopefully this is helpful. We will go over any questions we have tomorrow in class. Otherwise, be well, take care, and I'll talk to you later.